Right then, rounding again, minima and maxima. Now, minima and maxima are, it's like thinking backwards. If something's being rounded, say to the nearest centimetre, a table is 60 centimetres long, right? So if you've got a table which the nearest centimetre is 60 centimetres long, then a minima and maxima are the minimum possible values that table could have been, the minimum length and the maximum possible length. Okay? Now there are plenty of lengths that would have rounded to 60 centimetres. So for example, you could have had 60.3 centimetres would round to 60 centimetres to the nearest centimetre. You could have also had 59.7 centimetres which would round to 60. Okay? Minima and maxima are the minimum possible value and the maximum possible value. Now in this case, the minimum possible value that rounds to 60 centimetres to the nearest centimetre is going to be 59.5 centimetres. That's your minimum possible value, because no value less than that will round up to 60. Any value less than that, it would have rounded down to 59. Okay? Your maxima value, so if I put that as that is your minima, okay? Your maxima value, okay? Now the maximum actual value that rounds down to 60 centimetres is going to be 60.49999, going on forever, so recurring. Now we can't always write or use 60.49 recurring. So what we do is we say the maximum value, okay, effectively is going to be 60.5 centimetres in this case. Okay, I know that 60.5 would round up to 61, but if you're going to use it in a question, then effectively 60.49 recurring is so close to 60.5 that we use 60.5. Okay, you'll also notice if you're rounding to the nearest centimetre, then the difference between your minima and your maxima values is 1 centimetre as well. Okay, how would we then use it in a question? So somebody's asked or posed the question, you're a company that has to make 5,000 tables. Okay, so this company has to make 5,000 tables, and these are for, say, a number of schools in County Durham that need a new set of tables. Okay, the company or the person working for the company has gone out and he's measured the table that they're going to copy, and he's measured it to 60 centimetres to the nearest centimetre. Okay, the people in the company then have to ask themselves, how much wood are we going to order for these tables? Now the minimum possible amount of wood that they're going to need is going to be the minimum possible value of that, minimum possible length of that table multiplied by 5,000. So the minimum value is going to be 59.5 multiplied by 5,000. Okay, and I'll do that on the calculator. 59.5 times by 5,000. Okay, that is going to equal, when you cancel it down, 297,500, so 297,500 centimetres of table, or wood in this case, and which is the same as saying 2975 metres. Okay, so 2,975 metres. What's the maximum possible wood that's needed? Well, it's going to be 60.5 multiplied by 5,000 again. Okay, in centimetres that is going to be 302,500 centimetres, and in metres that is going to be 3,025 metres. Okay, the difference here between your two values is going to be 50 metres of wood. So it's important, because 50 metres of wood might not be very cheap for the company. If they didn't, say the person had gone out and measured it as 60 centimetres to the nearest centimetre, and it was actually 60.5, then they're going to be short 25 metres of wood if they order it. If in the other case the table is actually 59.5 centimetres, then they're going to waste 25 metres of wood. So the answer then, you're going to have to go out and re-measure the table. But these would be your minimum amount of wood used and your maximum amount of wood to be needed.